Hello and welcome to my next part of this two-part series for this bullet hell game that we're making in Unity. So far what we have is we have a little character that moves around, bound to the edges of the screen. Enemies spawn across on the right hand side and move across the screen. We have to dodge them, and if we get hit by one of them, then we lose and we have a game over. So we actually have some gameplay, but in part 2 we're going to expand that gameplay. Let's think about what kind of additions we can have for our gameplay that we will spruce it up. The first thing I've noticed that we probably need to solve before we add anything too funky is the fact that, we're constantly spawning these enemies in. So if I go ahead and pause the game while it's still running, I'm going to click on one of these enemies and press F to focus on them. It's a bit too focused, but yes, here we go. Here's the view of our actual game running, and you can see as the game continues, and even after I die, the game will keep spawning in these enemies, and they're just going to spawn forever. Eventually, there'll just be too many of these enemies, and the game will basically crash. So if we want our game to last any longer than 5 minutes, then we probably want to get rid of these enemies once they're far off the left-hand side of the screen. So let's go ahead and create another timer on the enemy so that after a certain amount of time, they'll destroy themselves once they've gone off the edge of the screen here. Let's go ahead and open up our enemy script so that we can quickly add a timer. Let's create a public float, which we'll call a life timer. We'll have a public float, which will be the max, which will be, say, lifetime. Simply in our update, so let's go ahead and make an update. This is a fixed update method, so I think I'm going to make an update method just so I can put this timer in it. I mean, you could really have a timer and fixed update as well. Either one works usually for most simple things. The difference between update and fixed update is update will happen every frame. Fixed update only happens every frame that there is a physics render in Unity, which is not necessarily every frame. It's sometimes gaps of 3 to 1 frames between. So I'm going to do life timer is plus equal to time dot delta time. So this is just going to count up and up and up. And once it gets to a certain value, in this case, if the timer is greater than or equal to our lifetime, which is the max number this value can be, we're going to destroy game object, which means the game object that this script is attached to. So once I save this, after a certain amount of time has elapsed, it will just destroy itself. So it won't stick around forever. And as we spawn these in, they should also then disappear once they get far enough. Pardon me. So we've basically programmed mortality for these enemies instead of being immortal. All right, so let's see. To make the change, I'm going to click on this enemy and make sure I have the enemy prefab selected so that whenever I make the changes, it will be reflected on all of the instances of that enemy that get spawned in. So our timer should start at 0, and our time, well, how long does it take to get across the screen? Let's go for 4 as the value, be conservative and see. Maybe it actually takes longer than 4 seconds to cross the screen. Yes, look, you can see they're all disappearing a little too early. So keeping in mind, it doesn't really matter if they exist off the left-hand side of the screen for a while. So I'll go ahead and put this up to 8 seconds because I know that should be, definitely they should be off the screen by the time they instantly destroy themselves. And now if I go back to the scene view, I can see they're all sort of hopefully disappearing after a while on the left-hand side. There we go. So we never have too many enemies spawning in. They are destroying themselves eventually. So no gameplay change, but we've sort of future-proofed our game so we can continue to fly around avoiding all of these enemies or bullets or projectiles or whatever they are. But they aren't really projectiles, are they, at the moment? One of the things, I'm going to go ahead and have a look at a bullet hell game again. We need more bullets, more things to dodge. One of the things that happens often in bullet hell games is, oh, this is an album. Let's see. Is this going to show us some bullet hell games? One of the things that the enemies do in bullet hell games is they fire projectiles at you, which means you have to keep moving around. It's not just as simple as our game, where everything's moving from right to left statically. So let's go ahead and add the two features. We're going to add the fact that we can shoot at the enemies as they're spawning on the right, and that they can shoot at us. So let's start. What should we start with? I think we'll start with the enemies shooting at us. But really, whenever we think about it, we should be probably creating the logic for both at the same time. So let's go ahead and create a projectile. And I'm going to go ahead and say we're going to create another 2D object in our scene, which is going to be a sprite. And for now, I'm going to be really lazy and make the projectile be the same sprite as the enemy, but we're going to recolor it. We'll make it, maybe this isn't going to work. Okay, we'll make it like a blue for the, or a really bright pink for the enemies maybe, and we'll make it half as large as well. So this is like the laziest thing I've ever done. In your version, you can make a much better game by creating your own new sprites for these projectiles as well. And I'm going to call this one enemy projectile. So you can see it doesn't currently have any colliders on it. Actually, our enemy wasn't a 1 scale. It was 2 scale. So actually our projectile could be maybe just 1 scale. Let's bring it down and see. Okay. Why can't we see it? Oh, I think I've made a mistake. The Z axis for some reason set to 0. It should be set to 0. It was set to like -22 or whatever. There it is now. So that projectile looks like it's about the right size. Now we just need to add a script, which could be our projectile script. I'm not sure what way we'll do this yet in terms of the enemies and the player, but let's just do the enemy projectile for now. And then, should we use a rigid body? We could just move it towards the player and without needing the rigid body for this one. So we'll not use the rigid body. However, we do want the collision to happen, so we are going to add the circle collider 2D. And we're also going to want to make is trigger true. That way we can check if we collide with the enemy. However, actually, now that I think about it, we are already detecting the character death whenever the player collides with something with our player on trigger enter 2D in the player movement script. So instead of having the enemy check if it's collided with the player, we should probably be consistent and have the player check if it's collided with the projectile. So I'm actually going to turn back this to normal. So we're not going to use its trigger on the enemy. So, okay. We haven't yet spawned in this projectile, but once it is spawned in, it needs to probably shoot towards the player. But we don't want it to track the player. You know, once we shoot the projectile at the player should be able to move out of the way. The bullet shouldn't just home in on their position. So probably what we want to do is at the start, we're going to want to grab the player and head towards it. So I'm going to make a public game object, which will be our player. Or maybe it's a transform because it's the position we care about. So we'll do player public transform. And now at the start, we're going to set a vector, which is going to be our movement. So vector 3 direction is just going to be called. Make it public as well, just so we can see it in Unity. And at the very start, we're going to set the direction, and it's going to be equal to moving towards the player. So a classic way of getting a vector is to get the difference between the target and the current direction. So actually, if we go ahead and take our current target, which is player.position, and we take away our own transform.position, what we end up with is the difference between those two positions, which is actually the direction between those two. Think of it as being if you have two relative positions, let's say they were both on the same point on the y-axis, in this case y is 0 and y is 0, then the direction is going to be, let's say player position y was equal to 1 minus transformed position y is equal to 1 as well. Well, that's going to cancel each other out, so y is 0, and that makes sense in the direction. The direction is also on the y-axis 0. And then if our player position is behind, like it's, let's say our player position x value is 1, but our projectile value is 3, then if we take away the projectile value, position x, so 1 minus 3 is going to be minus 2, which means then our direction is minus 2, which is from here in that direction, which is pointing towards the player. Maybe I need to do some sort of visual breakdown of that in the future, in a future class. But really the idea is that if we take our target position and we take away our current position, we get as a vector 3 direction the direction to that target. So anyway, we're storing the target, and it's important to note here we're storing it at the start when the game runs, rather than an update. No, sorry, I misspoke there. So far we've been using the start method as when the game runs, but actually it's whenever that instance first comes into being. So, you know, at the moment we've got our player, so that means it will run the start method at the very start of the game once we hit start. But for our projectiles, they're going to be spawning in as the game plays, so they're going to be doing this just the moment that they spawn in. So we've now got our direction, and subsequently we're going to go ahead and use that direction to move our object, and we can just go ahead and do transform.translate, which is very simple. This is a method of our own transform, which is going to take a vector 3, which is the direction, and another value for the movement. So we're going to go ahead and say the direction is where it's going. And actually the amount that it moves by is going to be the magnitude of the direction, so the value. So what we're going to do for that is we're going to normalize the direction so that the magnitude of this vector is always the same no matter the distance between these two. And then we're going to multiply it by, you guessed it, time.delta time, and also multiply it by the speed. Let's go ahead and make a public float speed. So this is getting a bit complex because we're doing a lot of coding without actually running the game yet. If I run the game, then it's going to give us an unassigned reference exception because we haven't told the projectile about the player. It doesn't know what the target player is. So let's go ahead and set the speed to, well, it better be faster than our enemies or else the enemy will overtake the bullet it fires. The enemies are currently running at 200 speed. So let's make the projectile be twice as fast, 400. We can tweak these values to our heart's content later. Then we're additionally going to drag our character, which is the transform target for the projectile to move towards. Oh my goodness, it just disappeared. I think the reason that that we were using 200 and it's such a high value is because we're using our rigid body, which has like drag and things like that. Whereas whenever we're using our enemy projectile, we're just moving it directly without the rigid body. So that means I think 400 is far too fast. Let's go ahead and put in 4 instead and see what happens when we run the game. Ah, there we go. That looks about right. In fact, maybe it should be even faster. Let's go 6. There it goes. I mean, presumably that's towards me. Let's move the projectile up into this corner just to make sure that it moved diagonally down towards us. There it is. Now here's the problem. Once we make this enemy projectile a prefab, oops, don't replace the enemy one, make it a new one. There we go. Whenever this enemy projectile spawns in, it's not actually going to know where the player is, because look at what happens whenever we make the enemy projectile a prefab. We have this player is set to character, this variable, but within the context of the asset itself, it has now been set to none again. And that's because we cannot interact between the scene and the prefab. It doesn't know which scene it's going to enter, so it can't set up those relationships between the prefab and the assets folder and the asset prefab that we instance in, that we spawn in. So basically, we're going to have to come up with a way in code to give it this information of what player it should be going towards. The easiest and sort of cheaty way of doing that is just to find the player based on this player script whenever we spawn the projectile in. In this case, I'm just going to go ahead and do is it GameObject.find, which is a Unity default method which allows us to find all of the scripts of a certain type. In this case, we're trying to find whatever object has this player movement script. So I'm going to do find, and the type is going to be player movement, and it's going to be find object. Now this doesn't look right. I think I'm doing something wrong here. Maybe it's not a game object method, it's just one of these. Find object of type. I think that's about right. The object of type that we're looking for, that we put inside these strange little brackets here, is going to be the player movement. And these strange little brackets are basically like an argument that you would normally see. It's just that they are looking for a specific class type. And that's why they're a little bit different. So once we find an object of that type, it's going to return a player movement. So that means we're going to assign our player transform to that. However, whenever we do this, we're going to get an error because we've got a player movement class and they were trying to set a transform. So we're going to have to go dot transform to get the transform of the player movement class that we just get from this method to then feed into our player. So let's go ahead and test this out. I'm going to go back to my enemy. I'm going to drag in a projectile. So up here in the top corner, we're going to see, look, we can check it starts with none transform, but whenever we run the game, it should hopefully find the player and move towards it. Oh, look, we even died from getting hit by the projectile. All right, so the last thing we're going to want to do is have the enemies spawn in the projectile. So I'm going to make another game object reference within the enemy class, which will be to the projectile. We're probably going to want to use a timer to spawn in these projectiles. So we're just going to do the same thing. I'm going to copy this. So it's going to be like fire timer. So every, fire, not as in fire, like, oh my goodness, the theater's on fire. Everyone escape, but fire is in firing the guns, firing the projectiles. And we'll do the same thing, which is fire time. I mean, we could say fire rate as well, be more thematically satisfying. So once the fire timer gets to a certain value, we're just going to do copy paste this code. The fire timer is going to go plus equals time.delta time. Our fire rate is going to be the thing we check. So once the fire timer is greater than or equal to fire rate, then, well, we're not going to destroy ourselves. We're going to instead fire our projectile. And what that means is we're going to just go ahead and spawn the projectile in. So instantiate. And again, we've done this before, right? We've spawned in an enemy. So I could look at my spawn manager and go, oh, look, that's the code there for spawning in an enemy. So we're going to do something similar. Instantiate. We've got prefab, the position, returning an identity. I'm going to copy this, go to our enemy, paste it in here. Only it's not the enemy prefab we're spawning in, it's the projectile. It's not new random position. It's going to be, well, where are we going to spawn it? We'll spawn it the same place. So it's going to be transform.position. That will just get the position of where the current enemy is. So the projectile will start there. Let's go to our enemy and we can get a reference from our enemy to the projectile. So we drag the projectile in here to the projectile script. Let's change our rate of fire to being every second, let's say. I think this will be a lot of projectiles. Oh my goodness. Whoa. Whoa. Well, it's certainly spectacular. That's why I like coding video games, sometimes your errors are like hilarious looking. So we've clearly made some sort of big mistake here. I think that we're just spawning in all of these objects because whenever we get to this point here where the fire timer is greater than fire rate, we are not resetting the timer, which means we just from then on spawn in a projectile every single frame. So once we fire, we're also going to reset the timer to 0, so then it will start the timer again before we fire again, and so on. There we go. I mean, it's now basically impossible. Also, our enemies are all spinning around, which is hilarious. I think it's because our physics interactions are causing the bullets to hit the enemies and sort of bump them out of sync. Yeah, they're spawning in on top of the enemies, and now it's pretty impossible. So I'm going to go ahead and go back to my enemy, and we're going to prevent them from being moved around. One of the easiest ways of doing this is probably just to go ahead and freeze their rotation. Really, we don't want these things to collide at all. We don't want the projectile to collide with the enemy. So I'm going to go ahead and introduce our physics layers, which is a new thing. So you may have noticed in our inspector window, we've got this layer here. One of the things I can do is I can change those layers. So instead of being default, I'm going to add some layers. I'm going to add a layer which will be for the enemy. I'm going to add a layer which will be enemy projectile. And I might as well do the same thing for our player and player projectile. This way I can specifically set up the matrix of collisions. So I've done this. Let's see, I'm going to go to window. Let me see if I can remember where this is. It's in sort of like our physics management. I'm trying to remember which of these things it's in. Let's see. It's presumably in here somewhere. Well, when all else fails, Google. So I'm going to go ahead and Google our Unity physics matrix. Matrix with an X. This is the thing I'm looking for. It's in Edit Project Settings. So I'm going to go Edit Project Settings. And I'm going to go ahead and find our physics. Here it is here. Though I believe it's physics 2D, which is basically just the same thing as physics, but with the 2D version, right? So here we can see from a matrix of all of the different overlaps of what will collide with what. So I'm going to go ahead to my enemy projectile and say I don't want the enemy to to hit the enemy. So I'm going to go enemy projectile, and there's the enemy there. So the enemies shouldn't collide with enemies. In fact, the only thing that enemies should collide with is the player. The only thing the enemy projectile should collide with is also the player. And similarly, the only thing the player should collide with is those things as well. The player shouldn't collide with the player projectile. Oh yes, but the enemy should collide with the player projectile. So I'm going to go ahead and say enemy. Let's see, where's the player projectile? There it is there. And there's the enemy. So that should hit that as well. Let's see. So the enemy projectile just hits the player. The enemy hits both the player and the player projectile. I don't know. That seems about right. So now whenever we run the game, hopefully our projectiles won't hit our friends. Well, they are currently because we haven't set any of the layers. So I'm going to go to my enemy. I'm going to set this layer from default to enemy here in my inspector window. And I'm going to set my enemy projectile to enemy projectile. And I'm going to go to my character and set the layer to player. And we haven't done our player projectile yet, but we'll have set that up already. So now, look, there we go. This is much better. No, but that's basically impossible. And also whenever our character dies, we sort of get this error and it all sort of goes a bit crazy. But It's looking all right. I think we just need to turn the rate of fire down on our enemies. You can tweak this yourself. Fire rate is 1 second. I'm going to change that to every 3 seconds. So now these projectiles will only shoot every so often. Though you can see they do all sort of shoot at the same, roughly the same speed. I think because we've got bullets now, we maybe need fewer enemies. So I'm going to change the spawn timer for our enemies. We're going to triple it. So there are far fewer enemies. But now the enemies should shoot at us. In fact, probably what we want is we want really far fewer. Like, yeah, this looks good, except we maybe want our enemies to fire more now as well. Again, so I'm just tweaking some of these values. You know, you could really be here all day tweaking values and trying to design the game. Let's have a look at this now, whenever they fire a little more. I think, let's see, what happens in bullet hell games? Do they, are they able to fire at you whenever they go past you? Or maybe they only fire at you whenever they're to the right of you? Because I don't remember having to dodge bullets that come from the left to the right in a bullet hell game. I'm pretty sure you only have to dodge bullets that go from the right to left. So if you like sort of go past an enemy, it no longer shoots at you. So we're going to go ahead and add a check to that measure. So not only does the fire rate have to be plus or equal to fire rate, but also the enemy, the player, is going to have to be to the left of the enemy, so that the enemy will never fire backwards at the player. Well, the enemy isn't currently keeping track of the player, so let's just copy that code from whenever we did it for our projectile. So I'm going to go ahead, copy this. It needs a variable to keep track of where the player is, and also whenever we spawn in, we're going to grab the player with this code. And now the enemy has a reference to the player. And we're going to check, so we're going to use an and here to check if the player dot transform, which is dot position dot x value, is the x value less than transform dot position dot x. In this case, we're basically saying, is the player to the left of us? Is our x value greater than the player's x value? And now it will not fire a projectile unless that is the case. Let's go ahead and check this gameplay change. So now, flip's sake, I'm so bad at my own game. Maybe I just need to turn the speed up of my player character. So now if I go past the enemies, you can see they no longer shoot at me. I'm going to go ahead and maybe I just need to slow down the projectiles a lot as well. That's another way of making them easier to avoid. So I'm going to change this back down to a speed of 3. The projectiles are a lot easier to dodge now, but they're still shooting whenever they are behind me. Look, do you see? Where are they? What's going on here? Something's not right. We need to debug. They aren't shooting when they go behind me, but some of these projectiles are moving from left to right. So I wonder why that is. Let's see. In fact, look, these projectiles are just going completely the wrong way. I think our code is wrong. Something's not working. They're not shooting at me. They're shooting in strange different directions. Whenever we run the code, does this null reference exception come up? Is that a problem? Or is that only once we die? I think that might be only once we die. Okay. So let's try and debug and see what's going wrong with our projectile. The projectile is currently trying to translate towards the enemy, towards the player. I think the problem is this normalize, perhaps. Let's try getting rid of this. I don't think that is the problem. So the normalize is to change the magnitude so that it's only 1. Oof, that's what happens whenever I get rid of the magnitude. Whenever I get rid of the normalize. Or we've got our player position, transform.position minus equals. So maybe the problem is that whenever we spawn in our projectile, it's not spawning in the right position. So let's go ahead and check and see whenever our projectile spawns in, is it secretly in a completely the wrong place? So I'm going to go back to the 3D view and focus on it, and you can see no, it looks about right. It's got, look, it's 6 minus 3.8. But you can see, look, it's heading in completely the wrong direction. It's supposed to be moving towards the player, but the projectile is moving up and to the right. Or is it? Or does it just look like that because of the way the enemies are moving? Maybe I'm literally tripping here. Do you know what it is? It's actually, it looks like that this is an optical illusion. Oh my goodness. This is interesting. It's because the projectiles are moving slower than the enemies. Let's see what happens if I put the projectile speed up to say 4 and I put the enemy speed down to all the way down to 50. I think I just bamboozled myself with an optical illusion. Now the enemies will move very fast, slowly, and all of these projectiles will be headed. It looks like they're headed towards me. Oh my goodness, I just bamboozled myself with an optical illusion of objects that are moving more slowly than others. Wow. But this is almost like more fun gameplay. This has been quite a rambling tutorial, I'm afraid. Sorry, but this is kind of what happens whenever you start to meld the worlds of coding and design. You can really get lost for hours changing little bits and pieces of just variables. And that's kind of one of the fun things about learning to code yourself, is you can start to design at the same time as create and iterate and change little bits and bobs and see what does make the most fun gameplay. What's missing from the current form of our game. So I think this is a bit more fun than it was before. If I go ahead and change the enemy speed just a little bit, let's go ahead and make it all, maybe like 80 instead. Maybe this will be more enjoyable experience. But I do want to move on and implement something else here. Now our timer isn't long enough for these people to survive. But look, I think I've got a bit more of a bullet hell kind of experience here now. So let's go ahead and implement the last thing, which is our player should be able to fire and destroy these enemies as they shoot projectiles at us. And guess what? That will change our design, because with fewer enemies, because we're destroying them, we need to spawn more enemies and so on and so forth. Let's go ahead and make our enemy timer last far longer as well, just so that it doesn't disappear prematurely. I'll make it 20 seconds that it lasts for now that it's moving so slowly. Right. So we've got our enemy projectiles. So let's go ahead and make a player one. So I'm just going to go and duplicate this by dragging in this enemy projectile. I'm going to go ahead and change, nothing about it yet, but drag it back in. Now it's going to ask me if I want to make a new original prefab or a variant of the prefab it already is. I think we'll make an original prefab. So now we've got this enemy projectile 1. Let's change the name to player projectile. And we'll go ahead and delete the original. And we'll change the color from purple to say like a blue. So now we can spawn in our own. I'm going to make a new script for it, which will be a new projectile, which we'll call player projectile. But really, it's going to be very similar to the enemy script. So let's go ahead and take a look at what the enemy projectile script looks like so we don't forget. So here it is here. I'm going to copy paste the code, but I'm going to make sure that I don't copy paste the code that's outside of this class. I'm just going to copy paste the code that's inside the class, because, for example, the class here is called projectile, but the class for our player projectile, when we open it up, you can see it's player projectile, and all sorts of horrible things would happen if we pasted over that and changed this so it wasn't the same as this, but it was the same as this. Oh my goodness. So Now we've got pretty much the same code. The only difference really here is that we should be not, we don't really want to shoot towards the enemy. We just want to shoot across from right to left. So we don't even need to do this. The direction can just be actually a new vector 3 1 0 0, which is going to be just, that's basically to the right, right? It's not up or down, so 0 on the y-axis. It's not z because we're not using it because it's 2D, and we're 1 on the x, which just means going across, because this is negative value going to the left and going to the right is a positive value. So we've got our direction, and we're going to translate it using speed. So we've got our player projectile. It's going to go ahead and be on the layer player projectile as well. We're going to have to make sure we set that up, or else we'll end up shooting ourselves. We'll shoot the bullet and it will immediately collide with us and we'll just immediately get destroyed. We're going to set our speed. Should our own projectile speed be faster or slower? We could be here all day. I'll set it to 4 and we'll see what happens. And finally, we're going to go ahead and actually spawn these in. So once again, I'm going to go to the enemy. I'm going to copy the code for spawning in the projectiles. We could like only do this while we're pressing spacebar or something to fire. That would be easy enough to add later. But for now, I'm just going to make our character fire automatically. So we're going to copy this, which is going to be our projectile fire time and fire rate. I'm going to copy this into our player movement script. So we've got these variables, just like our enemy. Just like our enemy, we're going to do a fire rate, and when we fire, we're going to instantiate. We don't actually have an update yet, so I'm going to make a new one here. So public update, and then copy paste this code in. Now it's not the player that we care about. In fact, we never care about this. We just care about the fire rate for our own projectiles. We're spawning in our projectile. Transform position is going to be where our player is. It all looks same to me. So we're going to save this. We're going to make sure that we set up the relationship. So our character is going to need to know what projectile it's going to spawn in. So projectile says none. Let's go ahead and drag our player projectile in here. And now we should have our very own projectiles to shoot. Well, we're shooting them every frame. I think we're forgetting to reset our fire timer. Oh, I know what it is. It's because our character's fire rate is 0 at the moment, which means it's firing every single frame. Let's change that to be 0.5. We could have a fast firing rate. I think that generally looks quite cool. Ooh, maybe even faster than this. Let's make it 0.3. So now our little player is firing its own projectiles. Pew, pew, pew. Now it doesn't actually do anything when it hits the enemy there, apart from sort of like spins them off into space, which is quite funny. So let's go ahead and make our enemy react to getting hit. We're going to kind of do the same thing that we did before with the player. Look, let's go to our player movement. So it's important to sort of know where your code is and what it does, because that way you can just repeat code and change things over. So we're going to copy paste this on trigger enter 2D onto our enemy. So when the enemy gets hit by something, it's going to destroy itself. But we're not going to say game over because, you know, the game isn't over when we destroy an enemy. It's only over when we are destroyed. So there we go. We're going to spawn. We're going to destroy the enemy when it gets hit. And finally, I'm going to go ahead and set my enemy to is trigger. And that way, it's not going to collide with anything except whenever it does, it will get hit. So this is where our collision matrix really came into play, because we don't want the enemies to collide with their own projectiles, and we don't want us to collide with our own projectiles either. All right, nothing has health at the moment. Everything just instantly dies, but we've now got a bit more of a game of shooting the enemies, which is resulting in a much easier game because we can almost shoot these enemies before they even come onto the screen. So we can go ahead and do another bit of design and go ahead and set our spawn time to something really fast, like 0.1. Now enemies are going to spawn all over the place, but now we have the projectiles to try and shoot them. Oh my goodness. This is like flipping impossible now. Lots of development, lots of iterating over designs. Lots of little tweaks. One of the things we probably want to implement as soon as possible is having our enemies have health so that we can have a compromise between spawning in loads of them and also having a high rate of fire. I'm going to go ahead and set this back to spawning every 1 second. And let's add an enemy health. So now whenever we get hit by something, we don't want to just instantly explode, but instead we're going to have health. So this is going to be quite simple. I'm just going to go ahead and say public int, which is max health. So that's the max health our enemy has. And then we're going to have an int, which will be our current health. So instead of being destroyed, in fact, we don't even need max health because we can just set current health up in the prefab. So the current health is going to go minus equal 1. So we got hit, our health goes down. And we're only going to get destroyed if the health is less than or equal to 0. So this is just how many times it needs to get hit. So I'm going to save this. And because of the way we've set up our colliders, hopefully this will work. Let's go ahead and see if this is going to work. Let's see, we've got our enemy. We're just going to set our current health to start with at 5, and now it will need 5 hits before it will get destroyed. Hopefully. Things never work out the way you think they're going to. But let's have a wee check and see. Our bullets are just sort of going through them until eventually they get destroyed. I'm going to have to pay a bit more attention to try and survive here. There's not the same visual feedback that we might want of like, you know, them flashing red maybe when they get hit, but you can see they are eventually dying. This is a pretty hard game. All right, I'm going to leave it now for that as our second part of the tutorial. We've created a proper game. Our character is moving around, trying to avoid these projectiles and shooting projectiles out themselves. I think there's a lot of complexity to the code that we're using, but ultimately we're using the same kind of logic that we've already been learning before in previous tutorials. So you can see how the logic can get more complex, but you're not necessarily using more and more new concepts. It's just a combination of old concepts. You know, there's lots of features you could add to make this gameplay better. I highly recommend messing around yourselves with the spawn times and the rate of fire and see what you can come up with. I also recommend that you guys make your own sprites, and maybe you can make a much cooler looking game than I'm programming here. So I'm really interested to see what kind of stuff, what variant of this that you guys come up with by mixing around those parameters.